Today we're doing 8.2 angle bisectors of triangles. And recall that an angle bisector is when we have an angle, right, here's my angle, and it's cut by a bisector, and these two angles that it forms are congruent. So in this case here, we have our angle APB, it's being bisected by ray PC, and as it turns out, according to the angle bisector theorem, any point on that angle bisector is actually equidistant from the two sides. And this kind of makes sense if we think about it. So we could say that these two segments are congruent. Similarly, we can say that the converse is also true. If point C is equidistant from these two sides, we can say that PC is an angle bisector, so that it divides these two angles evenly. Okay, we'll do some examples. LM here, this is JKL. It's an angle bisector. We can tell because of these congruence marks here. So therefore M is on the angle bisector. MJ is 12.8, therefore ML is 12.8. Similarly, using the converse, we know that the measure of angle ABD, or we can calculate the measure of angle ABD, given that the measure of angle ABC is 112. Well, what's true about point D? We know point D is on the angle bisector, therefore this angle must be congruent to this angle, and they both must be 112. Oh, I messed that up. ABC. Sorry, good job if you caught it. ABC is 112, therefore it divides evenly between those two. To get 56. Okay, cool. See if you can go ahead and do these two. We're going to pause here.
Now it's time.
Please don't overthink these. We got 14.7 and 58 degrees. Okay. The next major thing you guys need to memorize is called the incenter. And the incenter of a triangle comes with a theorem. Yay! Comes with the incenter theorem. And it basically says that, that I should do pink? Okay. The angle bisectors of all of the angles of a triangle, so I do an angle bisector here, I do an angle bisector here, I do an angle bisector here, they're going to meet in the middle of a triangle. This middle is different than the circumcenter. This middle is called the incenter. The incenter, and as it turns out, it's actually equidistant from all the sides of the triangle. So that means PZ is congruent to YX, or YP, which is congruent to PX. So these three segments are congruent. Similarly, we can say that these, if we know that P is the incenter, we could conclude that BP is an angle bisector. Okay, we'll do some examples. Here's our setup. It tells us that JV and KV are angle bisectors. So KV and JV are angle bisectors. Therefore, I'm use pink here again, I guess. Those two angles are congruent. Those two angles are congruent. And we know that WV is congruent to V and a perpendicular line to this other side. It's not the perpendicular bisector now, it's just the straightest possible, shortest route to that side. It won't come up because they haven't marked it on here. But if we need to calculate angle VKL, so VKL, we need to calculate this one here. I'll do it in a different color. So I'm going to do it in what color, Renner? Red?
Yeah.
Okay.
No, it's
okay.
time.
We need to calculate this red angle here. Do we know any of the other angles? Well, we know this is 106. We know this one's 19. So we should be able to calculate this other pink one, this single pink one right here, right? That's also 19. So angle WJL is simply 19 plus 19, or 19 times 2. Similarly, we know from the triangle sum theorem that all the angles here should add up to 180. So angle L plus angle WJL plus angle WKL should all equal 180. And then we can just subtract it off to find WKL. Oh, they called it JKL. Yeah, WKL. Same thing. And then And then we take 1/2 of that, right? Because it's an angle bisector. Okay, you can get some water. That's fine. Okay, we'll do. Go ahead and do these two. So pause here.
Now it's time for that.
Yep. So this first one is 19.2. The second one comes out to 52 degrees. Okay, the very last section here is just a review of the difference between the circumcenter and the incenter. And we really need to have this down. In fact, there'll be other types of centers for a triangle. When somebody asks what the center of the triangle is, there are multiple answers to that, right? The circumcenter, it's possible for the circumcenter to be outside the triangle. The incenter is always inside the triangle, right? Because it's the product of these angle bisectors. So it must be equidistant from all the sides. Whereas the circumcenter is just the where all of the perpendicular bisectors meet, right? So we can imagine that here. I'll do the perpendicular bisectors. Boop, boop, boop. You know, they meet right there. Where the incenter is the angle bisectors. Boop, boop, boop. Okay, so let's complete this table. The circumcenter is the point of concurrency of the perpendicular bisectors. The incenter is the point of concurrency of the angle bisectors. The circumcenter is equidistant from the vertices. The incenter is equidistant from the sides of the triangle. And then finally, the circumcenter can be anywhere. It could be on the hypotenuse. It could be inside or outside the triangle. And then the incenter is always going to be inside. So we need to have these things memorized and be able to identify when we're dealing with the circumcenter and when we're dealing with the incenter. It's confusing, but that's why we memorize this list. Make some flashcards, study them, whatever it takes. Okay, that's it. That's all I got. Thanks.